live on YouTube. If they ask questions, they should drop it in the comment section. We'll respond to those questions, read them out, and we give response. So we are loading for us to join live on Zoom. Kindly exercise a bit of patience. Yes, we are live already. We'll respond to those questions. Yes, we are live already. You can hear the background. So we are 36, which is very good number. Even though we are not focused on number, we are focused on values. Because even after the training, it will still be available for further learning, further research, and for further administrative purposes. So let's start by introducing our speaker for today. Mr. Timothy is an ES Sustainability Analyst, Certified Project Manager, Certified Safety Professional, that is CSP, a Chartered Health and Safety Practitioner, and Integrated Management System Lead Auditor. He is highly experienced in managing critical environmental health safety issues, deploying energy efficient management systems, and also interpreting, developing, and ensuring compliance with the energy quality, health, safety, and environment management system. A direct and decisive leader with high hands-on management styles, highly skilled in planning, development, documentation, and implementation of quality, occupational health, safety, and environmental management systems. Risk assessment and management, environmental, social, and government, that is ESG. Greenhouse gas accounting and reporting, emergency response planning and implementation, accident investigation and root cause analysis, regulatory and statutory compliance, monitoring and coordination, change management, environmental assessment and social responsibility, and project management, like we said. He is a member of Board of Certified Safety Professional. He is a member of the Institute of Occupational Safety and Health, that is IOSH. He is also a member of the Association of Sustainability Professionals of Nigeria. He is also a member of the International Institute of Risk and Safety Managers, Institute of Safety Professionals of Nigeria, that is ISPON, and the Nigerian Environmental Society, ETC. He has a lot of them, but we can only mention a few. He has wide range of specialty, but I'm going to mention a few of them. Occupational health, safety and environment, oil and gas safety, process safety, quality and energy, MS, as 2001, 40,001, and 40,001, including 50,001. He is a certified trainer and an implementer and an auditor. He is a well-known, vast ESG and sustainability expert. So I'll welcome on the platform Mr. Timothy Aloko. Over to you, sir.
Good afternoon, everyone. Please, if you can hear me, kindly type on the chat box that you can hear me. Just type on the chat box that you can hear me. I want to be sure that I'm communicating with everyone. Okay, loud and clear. Okay, so thank you so very much, my friend Waliola, for this opportunity to speak. Although we've been dragging it for a while, and that's of course due to some projects, programs, and some professional activities that's really tied me down for a while, and we had to work this out. Of course, we would understand that there are a lot of senior colleagues on the chat. I think we have about 39 people on the chat. I might not be able to recognize everyone, but I recognize Engineer Khalid on the chat. I recognize all other colleagues. And I want to assume that some persons are players in the oil and gas, some are not, some are safety representatives, some are not. We want to thank God for this opportunity for us again to share ideas and bounce what we know. Well, maybe some persons on the call might even know more than us. So I'm always open to, that level of conversation, that level of discussion, such that we are able to rub our ideas and, all of us come out better and stronger and well equipped. Yes, so let me just share my screen and let's see how far and how well we can go. We started the conversation. I told Walio that, how do I speak about this topic? Considering that it is a very wide space. But again, we'll try as much as possible to make it, to bring it to to take it from the grassroots level, where non-players in the oil and gas on the industry will be able to grasp a little from. Can we see my screen?
Yes, sir.
Yes, so that non-player will be able to understand, because the oil and gas industry is a very wide, industry that touches on the upstream, the downstream, and the middle stream, with varying level of activity and risk measures, risk controls, risk impact, risk consequence, and the rest of them. So as much as possible, we'll just do a general overview. I don't know, maybe in the nearest future, our host will still organize a more extensive, maybe a 1 month or a 2 month class in different tablets, where we'll deal with the sectors each by each, and also the activities and the exposures that we have in the sector. So just to, what can you see on my screen, Waliu?
An overview, the flyer.
Has it changed?
Yes,
Has it changed?
Yes,
all right. So it is just, of course, I know a lot of us are players already, we know, but we won't place our judgment on that. There are a lot of people on this call that might not really know what aspect of what plays what, and, just to look at the industry and how well the industry is doing, and what are the different involvements, So we have the upstream, we have the middle stream, that's the oil and gas industry as a whole, and we have the downstream, where the upstream is basically about exploration and production. The midstream is about the infrastructure for energy. The upstream is where they discover the production of oil and natural gas, where they discover it in terms of fracking and the rest of them. The energy, the middle stream is about the energy infrastructure, where the transport of oil and gas via pipes and storages of excesses. Then the downstream is where the energy market users sit. Maybe I should just explain a little. The upstream and downstream, they are terms commonly used in the oil and gas industry. But do you know what they really refer to? For those that are not in the field playing actively in oil and gas. Of course, we know that professionals from diverse backgrounds, construction, power, food and textiles, hospitality, aviation, we have from different backgrounds. But for those that don't know, simply put, upstream work include the exploration. For the upstream now, it includes the exploration and production of crude oil and natural gas, whilst downstream refers to the processes applied after extraction through heat to being delivered to the customers in whatever format required. Maybe in terms of aviation oil, in terms of PMS, in terms of DPK, that's the kerosene, in terms of the diesel, the whatever, the butane, the whatever. So now delivery is the downstream, extraction is the upstream, then you have the middle stream too. Upstream exploration involves multiple activities, you agree with me, from acquiring of land rights to conducting geological survey, digging exploration wells to look for reservoir of oil and gas. It is a high risk activity for organizations. For those of us that are player, we know what it entails, and it is very expensive, and the cost is only truly recouped if the exploration is successful. There are a lot of exploration. You hear OML, this, OML, that. There are a lot of OMLs that you've heard of that doesn't exist anymore, maybe because they were not able to explore successfully, and there is no ROI. The return on investment only comes when the exploration is successful. Production covers the extraction of natural resource from the grounds. This covers, to a very large extent, drilling wells, either onshore, offshore, or fracking. What do we call fracking? For those in the oil and gas, they know that it is a process of when you inject liquid at very high pressure into rocks and bore, so as to force open the existing fixtures and extract oil and gas. Can you hear me?
Loud and clear, sir.
Okay. So the next
Loud
step
and
in
clear, sir.
process. All right. So the next steps in this process of refining oil and gas are referred to as midstream, middle stream works. You know, if you say upstream, that's the up side of it, the middle stream, the middle side of it. Of course, there are a lot of marginal fields too. I hope I would have time to talk about it and how they function. And of course, for the downstream, you have a lot of other oil and gas servicing with varying level. You have the likes of Baker Hughes, you have the likes of, you know, with Transocean, then, you know, with varying level of work activities, you know. So again, upstream works unsurprisingly rely heavily on technology and electronics. Modern exploration relies, well, largely on surveys conducted using sophisticated electronic equipment, which will likely form artificial intelligence and computer-based model of the area before exploration works. You know, before they go ahead to explore, I'm just trying to take us from the basics so that we can understand what the oil and gas industry is really, you know. So the down.
Can you hear me, sir?
Can you hear
me? You forgot to increase the slide size to fill the screen, to fill the screen. F5.
Oh.
Aha, yes. Beautiful.
I don't know how my system is misbehaving, but can we see it like this?
Yeah, it's clear. It's clear. Okay, it's fine.
Okay. Because I have, I wrote down some things using my screen touch pen. So if I put a full screen, I might not be able to see my note. However, if we just talk through whatever we, you know, as much as we can, you know. So wherever you can't see me, just let me know. So the downstream, there are processes. That's the final step of it anyways. Okay, you just started recording now, that's good. That's the final process of it anyway, that oil oil and gas takes from being in the ground to being in the hands of the consumer, you and I. You know, they are preceded by upstream and middle stream works, which, you know, covers the extraction and the rest of them. Now, the first step in downstream work, therefore, is refining. You know,
is it me? Can anyone hear me?
Yes.
I think
yes, we can hear you.
Yeah, I think
yes, I can.
I think we lost him. He's going to come back. I think that's a network issue. It's going to come back. Please kindly exercise patience. We just started recording. However, it's always available. How's it called? When we go live on YouTube, after the section, it's always automatically live available on YouTube. So it's like 2 ways of recording. But actually, you started recording again. So in case after the section, you might have any reason for us to go back to all what we've learned today, is always available. Please let's exercise patience while we try to get him back online. Like we said, network can be really funny. So we believe that today's training is going to be an enlightening one. It started by trying to explain to us the various sectors that are available in the oil and gas industry, the upstream, the downstream, and the middle stream. And that is where he is focusing on now in order to help us to get the background knowledge of where we are going to, because when we don't understand the background knowledge, it becomes very difficult for us to catch up with the pace of the training. Please let us exercise patience while we try to get back online. Thank you and God bless you. Does Engineer Khalid has something to tell us? Engineer Khalid, are you there, sir?
Yes, I am. I'm actually trying to reach out to our facilitator so that we can get back on track. However, what I would just do is in the next 2 minutes, I'll take over and do some preamble into the topic while we're getting back on track. So just I'm working with him now so that we can connect back immediately. But so as not to keep the audience waiting, in the next 2 minutes, if you are not back, I'll just engage just further on the topic while we have him set up. Thank you.
All right, thank you very much, sir. Yes, we have our facilitator back. Are you there, sir? Mr. Timothy Aloko. Okay, he's connecting now. Yes, you're welcome back, sir. You're welcome back.
My apologies, I had to switch my network. I don't know how Airtel just kicked me out of the call.
All right, it's fine, sir. It's fine, sir.
You're welcome.
Yeah, yes. Can you enable me to share my screen?
Yeah, I've made it a call, sir, so you can actually share your screen, sir.
It's still telling me host disabled participant screen sharing. You know,
Okay,
because I
okay.
went out, you have to do it again.
Okay. I check it now, sir.
Okay. Can you see my screen now?
Yes, sir. Very visible, sir.
All right. So I was speaking about, what happens at the refining stage where crude oil is then refined using, the fractional distillation, which is the common knowledge, where you get different products, gasoline, kerosene, and the rest of them. Remember that for all these levels of activities, there are equipments, there are machineries, there are the people doing it, there is the environment which they're working, a lot of exposures around people, equipment, environment, and materials of work, Then the crude is heated, fractional distillation works because these different products all have different boiling points. Like I said before, the crude oil is heated in the bottom of the distillation chamber until all the components turn into gas, which rise up the chamber. Those are just the common knowledge which we have, in this industry. Now, processing natural gas is a much more complex process. We'll touch on a little about process safety management, because to have a successful oil and gas system, you need a clear process safety management and also a clearer occupational health and safety management, which is the 45001, because of the people and the environment. Of course, if you want to now talk a little about the environment, we'll now talk about your 14001, the provisions, the requirements and the rest of them. So that is where you can say you have a robust, a sufficient, and a suitable management system to kick. Of course, it's about loss prevention and, accident prevention and the rest of them. So how does the middle stream works? This process comes between upstream and downstream in the production of oil and gas products. Once upstream works have been completed, the exploration and extraction of the raw material from the ground, we talked about fracking and, the natural, exploration system. And then middle stream work covers the initial process, like I said, the storage. A lot of us have gone to FPSO, both offshore, which FPSO, the production, the storage, and the, offloading and the rest of them. Then you now talk about your storage, transportation of the materials to site for further refining, maybe by land, maybe by barge, maybe by boat, maybe by trucks. There are a lot of trucks conveying crude and the rest of them, Then you now start at the point where it is delivered to the local refineries, maybe underground piping utilities and the rest of them. You now start, of course, you begin to imagine all those activities, imagine the equipment used, imagine the level of processes adopted, imagine the people that are doing the work, imagine the exposure to the environment when you see the stacks emitting uncontrollably and the rest of them. Then that brings to your mind that there must be a process to ensure that all these things are done safely. Remember, regulators are watching, and you have a whole lot of interested parties in that field, in the oil and gas field, a whole lot, both local, both unions, both international. You have a lot of, eyes watching the process. This process takes the midstream now, it takes the raw oil, which is a mixture of oil, natural gas, and natural gas liquids, and separates these components, a process which also results in water being produced. The water is either recycled or, that's a lot of stories, just for us to have an understanding of how it works. Then this is a further breakdown of the upstream. You can see your drilling wells and drilling and completion and well completion, gathering of pipes, that's to build the networks, upon which the midstream will ride, the production wells, the oil refineries, that's, taking what happens there initially as compared to what now happens on the downstream, the natural gas separation and the processing plants. Then you now look at the midstream, where you have the transportation, maybe via sea, maybe via road, maybe via rail, maybe, some level of underground networks, some level of storage, where you have FPSO, the HES there is for storage. Then you now have the pipes. Then when it now gets to downstream, that's like getting to where they want to refine and then subsequently use the product in terms of DPK, PMS, AGO, the butane, the cooking gas, the aviation fuel, and the rest of this is just to help us for those of us that are not in the oil and gas industry, to open our minds to a better understanding of how the industry works. Please, can I see on the chat box, can you type, now coming back to our Nigeria context, or even if you are not in Nigeria, I want to quickly see the chat box. Can you type the oil and gas players that you know, so that we can, I can be sure that we are all following? On the chat box, maybe feel free to type midstream, upstream, downstream, those in the marginal field somewhere around the midstream, those in the oil and gas servicing somewhere. In fact, from the upstream, downstream, middle stream, they are servicing everywhere. So can you just type, let me see if we are really in class together, because this is like an interactive, forum. Okay, somebody said Seplat, okay. Somebody said NNPC, okay. Total is both up, mid, and down. Yes, you have the total energy, you have the total at the drilling side, that's the upstream. Then you have Mobile, thank you. Matrix they're both, I think they're on the midstream, and on the downstream, you have Ajib. Well, Ajib is in the upstream and the middle stream, yes, but I'm not sure that they are on the downstream, Ajib and the rest of it. So that's good. That's good. Ajib is now, that's okay. So Shell, Mobile, Chevron, thank you so very much for all those drops. That means we now know, we understand. Maybe as a form of handouts, I can do a further breakdown of those that are in the upstream, those that are in the middle stream, and those that are in the downstream, and those that play utilities, that they have areas in the hub, in the middle, and in the downstream, so that we can now understand how this industry chain moves before it now gets to us, where we take our canisters, we take our cylinders as the general knowledge, to where we buy gas for our cooking, where we buy fuel to our cars, where we buy this to our generator. So the industry is a very, very complicated industry. If you go to the the upstream, you see a lot of rigs, you see a lot of, I don't want it to be too technical, so that some persons who have seen on the call that are just, trying to build up a career, can have a good understanding of what we are trying to talk about. Okay, thank you. So again, now, we have regulators for these industries. Of course, some will say maybe they are not regulators. Some were regulator and they are now active players. Some were active players and they are now regulators. Let's just put them together that they are regulators. You have the NNPC, which is now an active player, sequel to some level of commercialization that we saw recently. We have the Department of Petroleum who sets some level of tone, some level of guidance, some level of these. You have the Federal Minister of Environment where you get your HEGA spin. That's for those that are more into environmental part, where you have those exposures and what should be done and what is permissible and what should not be done. You have your Nigeria content, which sets, okay, this is the level of, okay, you are importing all this, let's say the downstream, you are importing all this equipment, you want to set up here, this is the level of those that should be locally fabricated. The NCDMB is just there to develop and to consolidate the Nigeria content of the industry, where we don't want all our monies to go abroad. We don't want all our jobs that can be done by Nigerians should be done by Nigerians. They give some level of NCD. They'll tell you load on JQS plan, load this, load that, so that they can be sure that Nigerians are generally empowered to eat out of what comes from their land. They tell you do this level of this level of that, just to be sure that Nigerians are well empowered. Nigerian market is well, visited in terms of consumables. How are we empowering our local market? NCDMB is there to regulate that space. We have NESRA for the because the industry has a lot of activities, a lot of refining activities, and gives way to a lot of harmful, when you are now talking about climate change, some persons we attribute a lot of it to. Of course, we witnessed a lot of things happening to Shell recently, the level of exposure, the level of emission, and the rest of them. So those guys are there. And NOSRA is also there in terms of spill detection and control. Of course, you would agree with me that because the product is channeled from upstream to midstream to downstream, using trucks, using underground piping, using some networks, using some silos, let me use the word silo, using some containment. So the spill is possible. And that's where NOSRA plays actively. NOSRA, they are there to play actively. You have the NMDPRA, that's the Nigerian Midstream and Downstream Petroleum Regulatory Authority. And you also have the local stakeholders. All these people are interested parties. Who are interested parties are those who your activities, one way or the other, benefits or the other will affect their daily livelihood. So you have the trade active guys. That these are people that play, that supervises, that sets the role, that comes every time to disturb you guys in your offices based on different level of exposures. Those are just the regulators. Let me look at
Yes, we can.
hello, can you hear me? Hello, can you hear me?
Yes, we can. I can hear you.
All right, so that we can have it more conversational, I want to drop a teaser I'll display it now. Please, admin, can you help me look at the hello? Hello?
Yes, sir, I can hear you, sir.
Okay.
All right, so can you help me put an eye on the chart? The first person to get this teaser correctly will get a gift from me much later.
Okay,
is it understood?
Sir. Well understood.
All right, so what is 3/7 chicken, 2/3 cats, and 1/2 goats?
Okay.
We have 1 minute for that. I will also be looking at, just put it on the chat box. Don't unmute your mic. Just put it on the chat box.
How come what is 2 something?
Yeah, you want us.
What is 3/7 chicken, 2/3 cats, and 1/2 goats? The first person to get it correctly gets a gift from me after this call. We have 1 minute for that. All right, so
And
I'm not sure anybody has got.
no, Chicago.
You don't say it, you type it.
I'm thinking this money.
You don't say it, you type it. Anybody that types it first gets it.
Okay, I've typed it already.
So a lot of us, you see, this is just to tell us that sometimes the problem is not as hard as we see it. Sometimes the solution to the problem is always in the question. A lot of us are already using our engineering maths, board maths. Let's do division before addition. No. The answer is simple. If you spell chicken, and you take 3/7 of it, you get chi. If you spell cat 2/3 is CA, then half of goat with the spelling is GO. So that's Chicago. That's to prove to us that sometimes we don't have to worry too much about issues. You don't have to apply a almighty formula. Sometimes the right response, the solution to the problem is in the policies, is in the procedure, is on what we have as a regulatory, maybe your PESTO analysis or your SWOT analysis and the rest of them. So the answers are always there. It is not always, because I know most of us are engineers, we like to solve the Y, the Hex, we like to solve, use board mass, use, almighty formulas and the rest of them, do a lot of integration, a lot of permutation and combination. No. Sometimes the solution lies in your regulatory handout. It lies in your factory hat. It lies in your, all your standard operating procedure. It is not as hard as you think it is, because the oil and gas industry is a well-regulated industry. Everything you want to do, everything you hope to achieve is in the procedure. Just read and look at it well. So like I said in my introductory speech, I said, of course, we want to look at the ideal. However, we know that for us to have a safe production and consumption that's walking from the upstream to the downstream, that it tells a lot on process safety and occupational health and safety. But again, we'll scratch occupational health and safety so well. We'll touch on process safety a little and talk about some process failures that happen in the industry that led to accidents and how those should be salvaged going forward in our different level of, works. I don't know if you work upstream, downstream, midstream, or you are, of course, somewhere around the marginal field, or you are somewhere around the servicing, which applies to all the streams, then you will be able to agree with me after this class. Now, then I'll briefly talk about how 18001 was first released. That's Occupational Health and Safety Management System, 18001, 2004, then it advanced to 2007, then before it now gets to where we are now, which is the 45001, which was released on the 12th of March, 2018. Third revision proposed by FDS, those are just things for us to know. Now, this is, be it in the construction, be it in the aviation, be it anywhere, the 45001, which is the occupational, like I said, there is the process, which is the very technical one, and there is the occupational. All of these things speaks the same language in the industry, except for some, criticality and some application. That's for the occupational health and safety. The requirement is clear from clause 1 to clause 10, and you have one as terms and definition. You have normative reference, all those, all those preludes before you now get to the critical management system requirement, which is from 4 to 10. Now, what do we now understand on the application of these in all industries? Good enough. Good news is that even if you are not yet in the oil and gas industry, or you are looking forward to be there, this applies to where you are, and you take it along with you when you have the opportunity in the oil and gas industry. If you look at some level of the, let's say, food and beverage, they have a lot of processing equipment. They have a lot of, these plants transfers through conveyor belt to these and the rest of them. So the machineries are somehow related. So you might bring a lot of knowledge from this section. So the 4.1, which speaks to understanding the organization and its context. What do we mean? You know that, okay, these are your internal and external issues. These are your interested parties. 4.2, the needs and expectation of workers and other interested parties. These are your interested parties. A lot of us may not know that. Like I said, the regulators I showed here speaks to, this management system integrates a lot of requirements and how it should, what should speak to what. The regulators I spoke about on this slide now speaks to 4.1 and 4.2 of this occupational health and safety management system. Remember that what we want to do is we want to maximize profit, we want to minimize loss, we want to conserve the environment, and we want to save our materials from damage, and we want to save our organization reputation, and we want to save life so that people come to the work and go back. And we want our equipment, our production, our refining, our extraction equipment to live up to perpetuity. What do I mean? For them to live up to the lifespan. If they say an equipment is 400 years, let it be able to live for 400 years. Let negligence and the rest of them not, affect the equipment, and let our environment be what it should be. And that's the sustainability, the climate change issues we're having these days. Now, so who are our interested parties? In some organization, you can make use of a SWOT analysis, which speaks to your internal and external issues, right? Your internal and external issues. Some organizations use SWOT analysis, which speaks to your strength, which is internal, your weakness, which is internal, your opportunities and your threats, which are external. Those to address your internal and external issues. Now, you will now want to understand the needs and expectations of workers and other interested parties. Of course, workers are also your interested parties. Now, you now want to use some organization. Who are your interested parties in terms of regulators, in terms of in the economic space, in terms of the political space, in terms of the social space, your technology space, your environmental space, and your legal space. And that's why some organizations use what we call PEST tool analysis. Remember that I mentioned that there are two wings to it. We are speaking about the occupational safety now, then we'll still speak a little about the technical and the process safety. Yes, so you now want to some large extent, you want to determine the scope of your management system. What are the interactions? What are the process interactions? What gives what using your PDCA? What gives what? What's the input and output of all the processes? So that the reason why you are doing all this is you want to create, like I said, your internal and external issues. You now want to create a schedule of fulfillment. How do you hope to fulfill all those requirements? What are the things that is expected of you? It is expected that you have your blowdown valve somewhere. It is expected you have your Christmas tree somewhere to reduce some level of pressures around, some of your valves and the rest of them. It is expected that you have some level of scrubbers on your flex stack. That's when you are doing your refining at the downstream. It's expected that you have your spill kits, those are the expectation of interested parties. What are the expectation of NOSRA, so that in case you have spill or such that you don't have spill, what are your, all those things, the requirements, you put them all together, that forms the basis for you to fulfilling your interested parties. Then you now want to talk about your scope. Where are the limitations of our management system? Okay, our management system speaks to this aspect of production, this, and that. Okay, what are the interactions? What are the process input and output? What are the level of controls? What are the operations, standard of operations? And what should be the, that will now make you to now plan your emergency response, plan your safety, operational plannings around all those level of activities. Remember that what is planned is measured, and what is not planned, you can't measure. And what is measured gives you success. if you are doing things and you are not measuring them and you are not monitoring them, and that's speaking to 9.1 of this management system, how do you now know the level of compliance so that you can plan your improvement 10.0? You know, this is a whole lot interwoven into, you know, your success, be it on the occupational health and safety front or the process safety management front. Then you now speak to your leadership, which is your 5.0. Do you have your clear leadership commitment in terms of their presence, in terms of resource management, in terms of you know, their inclusion and participation in whatever you do, in terms of their readiness to drive the management system, in terms of giving you the policy statement, which now sets the framework for objective and every other thing. This is, you know, the requirement is clear on the management system. We'll do this, the organization shall do this, the organization will do this, we expect this level of safety, would want to, you know, and some of your policies, it's set based on the management system and also on the performance of the previous year. Let's assume that you were able to cover some level of, you know, the policy is clear and your objective rights on the back of it, you know. So you might want to visit your management system to see what are the standard requirements and how to now, you know, in case you're already playing, how to now continually improve. How do you hope to continually improve your management system? How do you now hope to, you know, make them available upon request by all interested parties? Then you might now have to now walk through your organizational roles, responsibilities, and authorities. So you won't have a high level of retapism. You won't have a high level of idleness. You won't have a high level of non-compliance to lay down principles because people don't have the authority, you know, to decide and to play actively. Remember that if you don't want a level of micromanagement within your organization as oil and gas, as whatever you are playing, you need to set your authorities and you need to ensure that everybody is playing actively their roles and responsibilities. So that in some organization, you use what you call RASI, that's responsibility, authority, consultation, and information, so that you can begin to measure the level of success around your occupational health and safety. This also speaks a little to the technical, which we'll speak a little about it shortly. Then how do you now plan your action to address risk and opportunities? This is like a fatal flaw for a lot of organizations now because it wasn't in your 18,001 2007. You know, it is believed that, you know, beyond the conventional risk assessment, beyond the conventional, you know, job safety analysis, job hazard analysis, you now want to bring it to the broader picture of the organization as a whole. How do we now address process risk? How do we address, you know, when I mean process, I mean the different processes of the oil and gas, you know, the industry. It depends on where you play. How do you now address all those risks? And you would agree with me that if a risk is well mitigated, it presents an opportunity. So how do you now harness those opportunities? You remember that your 6.1 in your occupational health and safety management system speaks about this. Your 6.1 in your occupational health and safety management. Can you hear me?
Yes.
Can you hear me?
Yes.
All right. So remember that your thank you. So your 6.1 talks about that. Then if you now go a little down, your 6.2 now talks about how do you now evaluate the effectiveness of all these your controls? Are there risks that we didn't identify and it crystallized? Are there risks that we identified, we put measures, and, you know, of course, for those safety persons on the call, you know about residual and inherent. You know, I think Nebos uses residual, IOS uses inherent, or what have you. So those are the risks that are still there, even when all the existing additional controls and the rest of them have been put in place. What now happens to those type of risk? You know, that's why you should always measure evaluate the effectiveness, rather. That's why you must always evaluate the effectiveness of all those your processes. Then your 6.2 will now tell you about your objectives and how you plan to achieve them. What's even your, remember that all these things we're talking about, there are different procedures there in there out, different procedures to helping you. They would always tell you that for objectives, it has to be smart, but I will tell you it has to be smarter. It has to be specific, it has to be measurable, it has to be attainable, it has to be realistic, it has to be time-bound, it has to be ethical, something that is so aligned with the real sense of work. And it also has to be, someone has to be responsible. That's ethical and responsible. In some advance, you might hear some other things, but I personally use ethical and responsible, such that, how do you now put out this objective? Okay, last year we had just a simple scenario. Last year we had a fire from temperature build up on one of our boilers. No, 3 of our boilers. We've done the investigations. We've been able to identify the root cause and the rest of them. And what do we hope to do differently this year? You set objective around your successes and failures of last year. Okay, you succeeded to have 3 million man-hour of training and awareness last year, and you want to have 5 million this year. You want to train your operators, your plant operators. You want to train your boiler operators. You want to train your scaffolders. You want to train your riggers. You want to train your engineers. That's the production engineers. You want to train your completion engineers. So you now begin to build on your processes. And this is the ideal management system for any process. What speaks a little different is the process safety of it, which we'll still visit shortly. So again, you now set your objectives around your training, around your accident you had, and how you hope to reduce it in next year, around your participatory activities, around your regulatory activities. What are the issues? It's always good to set it on the issues you had the previous year and the successes you had the previous year to maintain and surpass what you achieved the previous year. Then you now briefly, what do you speak about your support in terms of your resource management, your environment to work, your provision of workspace, safe workspace, and the rest of them. Then your competence of your people, your riggers, is the oil and gas industry, your engineers, your equipment operators, your operators, be it your badge operator, all the operators. There are a lot of operators in the upstream, midstream, and downstream of the the oil and gas. So what are the competence matrix? What are the competence level? How do you assess competence? How do you reach out to competent workforce? All those are spelled out in the procedures under competence. Remember, competence has to do with knowledge, ability, training, and experience. This is more for we safety guys that, this lecture is more for non-safety guys will also benefit a lot from this because they would know what to do at every time. In the awareness, how do you hope to create awareness? Who should do what should be done? Your communication, both your internal and external. What is it that you want to communicate? Who communicates what? How do you ensure that the right information goes out? What's the channel of communication? What's the way to approve communication before it goes out? Not everybody speaks to the public, especially when there are issues. Those are, the management system expects everything to be planned in a way that, is in line with best practice. Then your documented information, what is it that you document? Who rates what? How does your documentation work? How does your discarding process work? How does your review syndrome work? All those things form part of your documented. Remember, there will also be a procedure for this, which speaks all those things, and there will be evidences, worksheets to fulfill all this management system we're speaking about. Then the critical part is your operations. Operations, where you now speak to all your operational planning and control. This deals extensively with your technical and process safety management. What are your, of course, the oil and gas, what you basically fight with, you fight with volume, you fight with temperature, you fight with pressure, you fight with what else? Who can remind me of what else? Let me be sure we're communicating. You know, those are when you speak about, we'll get to some example, you start speaking about valves, you start speaking about blow down, you start speaking about a lot of Christmas tree and the rest of them. It's not the conventional Christmas tree that we know. You know, a lot of things we'll be speaking about, Christmas tree, for those of us that are in the industry, we know that it's like a piece of equipment that provides flow control on a oil and gas well. You know, we know that. And Christmas tree, they are vertical assembly of valves with gauges and chokes that allow for adjustment in flow control as well as injection to stimulate production. You know, those are the operational controls which you'll be talking about. You know, then beyond that, oh, I can't see my screen again. Then beyond that, we will now be again talking about all other controls around people, all other controls around your equipment in terms of calibration, certification of your valves, calibration of your gauges, and all those things, your meters, calibration in line with 17025, that's ISO 17025, and the rest. A lot of operational control in terms of how do we do our toolboxes, how do we do our risk assessment for non-routine jobs, how do we do our job safety analysis, how do we, a lot of processes is under this operational planning and control, starting from your equipment certification, equipment factory acceptance testing, equipment commissioning. What are the things you do before commissioning? A lot of technical areas around this, which we may not, we are pressed in time to, we may not really be able to touch on those things. I think I have a little bit more time. We may not be able to touch on those things. Then you now talk about how do you now emergency preparedness? How do you do your drill for medical, do your drill for security, do your drill for blowouts, do your simulation for leakages, do your drill leakages, which is environmental drill, do your drill for, of course, a lot of us have only done the fire drill. Do your drill for medical. I've witnessed a medical drill on an offshore facility on a barge, and it was a great success where we did a lot of simulations and the rest of them. Do a lot of how prepared are you for real-time emergency? Then you now go deep into how do you now evaluate what is it that you want to monitor, what is it that you want to measure, what is it that you want to analyze, and what is it that you want to evaluate, and what's your sequence, your frequency of evaluation of all those things. Why are you evaluating? So that you can be sure that you are making some level of success, you are complying with all your interested party regulatory and the rest of them, so that you can be sure that your system is well in line. Then it's expected that you run from time to time internal audits with the laydown process. Of course, your all these criteria would be the requirement of the ISO and also your internal laydown process and the process of your interested parties, which are the regulators in this case. Then you do reviews and the rest of them. So that's just to speak us through a little of, well, maybe we would have some other forum another time where we'll go into details of how you ensure this is well integrated into your system so that you don't have much issues. Just to speak briefly about the process safety management, it has about 14 elements which we may not be able to talk about, but all process safety management systems should include process safety information. What are the basic information for everybody that comes into the plant? What are the safety requirements for every place and everywhere you go to? What are the limitations for visitors? What are the limitations for operators? Even the operators that has gone on leave, when it comes back, what are the quick fix induction that he does? What are the quick fix simulation that he does before he's been allowed to operate the equipment for drilling, the equipment for refining and the rest of them? What are the training syndromes and the rest of them? Then what are the process hazard analysis, which is more complex than your normal job safety analysis and job hazard analysis? The process that speaks to the real process that we are. Maybe it's an extraction process, maybe it's a mining process, maybe it's a refining process, maybe it's an offloading process, maybe it's a storage process. You know, there are a lot of issues around storage too. That's why you see trucks carrying this area, and there are a lot of road issues, transfer of dangerous goods. What are the real process hazard analysis? Have we been able to put one together? I have a sample of one which I'll display, which speaks to midstream, upstream, and downstream. It's a Can you mute your mic, please? So it's a bit very busy, but I hope we'll be able to make a sense out of it. Then your standard operating procedures, like I said, even for all the processes on the occupational health and safety management system, for all those clauses I briefly glanced through, that I briefly spoke about, there are a lot of processes that consolidate all those things. There are a lot of processes, there are a lot of procedures that you will put in place that explains what will be done by each clause and subclauses that we briefly spoke about, you know. And then your mechanical integrity checks, what should be done, what is the last rules, what are the calibration and certification, why do you calibrate and certify using 17025 with a standard, you know, there's what they call standard when calibrating, that's what you use to calibrate. What are the things you do to check the mechanic? How do you check for leakages? How do you check for what are your gauges speaking, your pressure gauge, your temperature gauge, your volume gauge? How do you, you know, there is a very, very complex process, very, very complex. Your extensive management of change. Oh, this is what is agreed, but this is what is available. How do we now, who is the change owner? How do we now communicate? How do we call a meeting to review? For all those major changes, there must be a review, and it also speaks to your process hazard analysis. What are the impact of this change on the integrity and safety of the entire workspace? Will it affect will it affect the loss production, which is a loss protection, which is our mantra? Will it affect the integrity of the organization? Will it affect the people? You know, we talk about the people, those are the three rocks of sustainability: your people, your profits, and you know, the environment, the place which you work, and the rest of them. What will it affect? Then a lot of other elements. Maybe one of these days we'll now drill down to the real technical place. Now, okay, let's briefly, I know we are already looking at the time, it's past 6. What are the issues? What are the hazards that we are so exposed to in the oil and gas industry? We have the pressure hazards, you know, the high pressure oil and gas from reservoir. Even during fracking, you are introducing liquid at high pressure, you know, into the substructure, which is the rocks or a well or what have you. So you have the high pressure, we have the vessel. Can you help me mute this person? You have high pressure steam from boilers and the rest of them. You have temperature hazards. You have high temperature compressor discharge pipe. You have low temperature at liquid nitrogen tanks and the rest of them. You know, you are dealing with different demons, with different issues in the oil and gas, you know, field. You have motion hazards, the rotating drill pipes, you know, the rotating motor shaft, the swing object during lifting and offloading, loading and offloading and the rest of it. You constantly do that. It's either you are transferring people from one platform to the other, you are transferring equipment, you are even lifting crude, you're lifting all those things. There are a lot of issues waiting, you know, to explode if you don't take care of those things. And that's why the safety is always top notch. Of course, you agree with me that even in the world or in Nigeria, the oil and gas industry is, they practice the safety more than any other industry. Well, that's left to some high-level debates anyways. So you now have your chemical hazards, the corrosion inhibitors, the lube oils, the exposure to people, to your skin through injection, inhalation through your nose, absorption through your screen, rather. You have all those issues. You know, we are not even speaking about the spill and the issues NOSDRA and NESDRA will come and drag with you if there are a lot of, you know, exposures, emissions, and the rest of them to the environment. Then the electrical hazard, the lightning, the electrical works. Of course, you know, most of those equipment are electromechanical. where you have the electrical part and the mechanical part. So how do you now take care of those exposures such that there is no unsafe interference? Then you have your gravity hazard in terms of slip, falling objects, heavy lifting, and the rest of it. You have the noise pollution around your generators, around your compressor areas. Of course, there should be a high level of dampening around those, so that that's in some level of sound engineering. You talk about dampening, and where that is not reasonable, practicable, you now begin to look at other administrative processes to mitigating the impact of that. Then you have your hazardous atmosphere gas release from vents, like the flare stack, where it's expected that there will be some level of, scrubbers, to purify whatever is going out into the atmosphere, the sulfide acid inside gases and the rest. The confined space, which is another terrible place to look at, work inside pressure vessels. How do you ensure that your gas meters are used to test the confined space? How do you ensure that you vent maybe naturally for 24 hours, or introduce your fans for 8 hours, 10 hours, 12 hours, till you are able to test with your gas meters to ensure those places are safe for people to enter? Because for time to time, it's subject to cleaning, because you might use it to transfer butane. This time, you want to use it to transfer any other thing, any other time, from the lifting batches and the lifting ships, vessels, the tanks and the rest of them, they clean them and the rest of them. Then excavation hazard, of course, buried onshore pipes, the issues around it, sharp object, radioactive, manual handling. Those are the critical issues that we are exposed to in the oil and gas industry. And if we're not too careful, we might get more exposures if we don't take care of those issues and nip them at the right places. Going by OSHA's process safety management, PSM, standard emphasize the management of hazard associated with highly hazardous chemicals and establish a comprehensive program for integrating technologies, procedure, and management practices. From 2016 to 2020, there were 386 fatal injuries in the private sector of the oil and gas industry. 386 fatal injuries. PSM aims to reduce the likelihood of these fatalities through careful planning, executing an oversight of operational hazards, and process changes. Several types of processes in the oil and gas industry, like I said, have the potential for chemical release that creates dangerous fire, safety, and health hazard. One example of this is the process of refining petroleum into fuel, which begins with distillation or fractionation. That's the fractional distillation that I spoke about, of crude into separate hydrocarbon groups. These groups are then converted into more useful products through cracking, reforming, and other conversion processes. Refineries removes impurity to improve product quality. No matter how routine these activities may be, it still poses a variety of safety hazards to the workers involved in it. There are a lot of areas we should touch on. Like I said, from the total mining, quarrying, all other mining, and oil and gas and extractive industry, 2020 looks a bit down. These are the issues we've had, in the past, for these 5 years. 2020 looks a bit down in terms of issues because 2020, of course, we all know that 2020 is the COVID-19 year. So the activities dropped. And since then, the oil and gas industry has really been struggling to, come back up to speed. Well, they are coming up to speed. And these are records of fatal occupational injuries in private sector of the oil and gas extraction industry. I wanted to go into details of this, but again, because of time will not allow. Maybe we would have another time of an extensive training to discuss more on this. Now, let's just take two failures, two critical issues that have happened in the industry. Of course, I'm sure we all know about the almighty Piper Alpha platform in the North Sea of United Kingdom, operated by Occidental Petroleum, that's Caledonia Limited. It produced 10% of North Sea oil explosion on 6th July, North Sea oil explosion on 6th July 1988, killing, remember, mark this, it killed 167 men. Who knows, maybe there are more. Only 61 people survived out of a lot of people that were on that platform that year. You know, total insured loss was about $3.4 billion. Wow. And this singular event still holds the world record as the worst offshore oil disaster in terms of loss of lives. I'm sure if I ask a lot of us some questions about, okay, what is it that failed? People would have a lot of answers. Oh, this should have been done. Oh, this wasn't done. Oh, why didn't they do this? These are medicine after death. Some persons will say the firewalls on Piper Alpha could have stopped the spread of the fire. They were, however, not built to withstand an explosion. The initial blast built the floor down, firewalls down, proper location and fireproofing of emergency shutdown valves are essential in order to cut off fuel supply. You will begin to hear a lot of things, a lot of reactive things. Then why are we waiting till then? And I'm sure they did a lot of work, but unfortunately, some things failed and led to that. We don't have time to discuss much on that. Another one is the BP Macondo, Deepwater Horizon US gone. Macondo prospect operated by BP. Of course, I'm sure those in the oil and gas, they've heard a lot about this, you know, this Piper Alpha, this Macondo, you know, operated by BP, resulting explosion in Deepwater Horizon semi-submersible rig. That's transition operated. 11 people lost and never found. Oil keep flowing from subsea well for 87 days until capped at 15 July 2010. You know what would have happened to the lives in the sea. You know what would have happened to the underground, underwater creatures when there is a consistent flow of oil for 87 days uncapped. Estimated 4.9 billion barrels total discharge to Gulf of Mexico. In July 2015, BP agreed to pay 18.7 billion penalties, the largest in US history, still holds the world record as the largest accidental marine oil spill. Now, this that I said is, should I say the direct cost? You might not know, of course, you know that there are two costs to accident, there are direct, there are indirect. You might not be able to estimate the level of indirect cost of this accident. Then why do we wait for them to happen? Of course, there are failures, but if you put all the measures in place and you timely evaluate, monitor, measure the performance of your equipment and your processes, you might be able to beat this down. So just one or two case studies before I give room for question. Now, this case study, there is high pressure oil and gas from the reservoir. What do you do? Using your hierarchy of control. Is it possible to eliminate? Not possible, since our goal is to extract oil and gas from the reservoir to the surface. And how do you extract at high pressure? So it's not possible for you to eliminate that process. What do you substitute with? It is not possible. Then the engineering will be that, okay, you install some blowout preventers, which is what you have in red. And the one in green, let me enlarge it a little so that we can see it, is called a Christmas tree that I talked about. Oh, I'm trying to enlarge it so that we can see. Can we see the Christmas tree? Hello?
Yes.
Okay, so during, you install blowout preventers during drill and Christmas tree during production. Those are just to regulate the pressures and every other thing. Then administrative, what do? You have your permit to work during drilling operations, and drilling standard operating procedures shall be strictly followed. This is what you do at this time. This is what we do at this time. This is what we do at this time. So that if everybody follows the procedure, there will be less issues to deal with. Then protective equipment, you want to ensure that your special PPE during drilling shall be worn. That's your high impact hand gloves that I have on this slide. So another case study, you have high temperature at compression discharge pipe. This is applicable to both the upstream, the midstream, and the downstream. then, how do you now eliminate this? It is not possible, since during compression, kinetic energy, there are potential energy stored in a place, there are kinetic energy which moves. How do you now regulate the high temperature, which moves, absorb, will be converted into it. As it moves, the kinetic energy, when the crude or whatever you are trying to, to discharge moves, it produces, of course, going to physics and some mechanical calculation, you can begin to calculate what is the level of, in what joule, what's the level of heat that will be, that will be generated, and the rest of them. So is it possible to substitute it? Also not possible. Engineering is now, because of the interaction from the outside of the pipe, we now want to do some pipe insulation. Just like I said, in noise engineering, you call that dampening, where they damp it so that they reduce the level of noise to the people. Now, in this case, it's called you insulate it. That's what you can see on your figure 3, which can withstand the maximum temperature of compressed gas. But the outer part is still cool. The inside is still hot, but the outside is still cool enough if touched by any human. Administratively, at least safety induction for personnel who will work at a compressor area and the rest of the PPE. At least PPE shall be worn, your hand gloves shall be worn, your vest shall be worn in case of any, well, God forbid, your shoe shall be worn, your shoe with an anti-grip surface, anti-slip surface shall be worn, and the rest of them. Those are the basic preliminaries. Then how do you now control the human factor? From a human perspective, controlling hazard must involve the knowledge and health, where people are subjected to time, health measurement, health checks, and special training is required for personnel working in dangerous locations like oil and gas industry. You know that it's a very, very high risk industry, and it's also very, very highly regulated industry. For people working on just visit to offshore facilities, especially when traveling by helicopter, they must do the boat search and the rest of them. The industry is very vast, and the lecture would have been more comprehensive than this. But because we say this is just an overview, of what should be, then maybe some other avenues would avail us with the opportunity to go deep into some areas where we can speak what the engineering people will be speaking, and how we can do a lot of process safety management, from our compressors to our, all the equipment, and now we can look at also the spacing arrangement, the minimum spacing arrangement. We can look at what should be the level of our valve protection, our our temperature relays, our temperature meters, our temperature gauges. You are dealing with temperature, you are dealing with pressure, you are dealing with volume, you are dealing with a lot of other exposures. With this, I would want to say thank you. In English, I would want to say danku and the rest of. So do we have questions for me? This is just an overview, and I hope we've learned one or two things from it. Thank you. Over to you, Waliu.
Wow. Thanks so much, sir. This is really a great overview, and you touched the salient aspect and important aspect that we need to know concerning what oil and gas generally means. And I personally really love the approach that you gave in using the ISO, the PDCA cycle to use that as an approach, and the use of the people, the process, the plant, the environment, and how the various hazards and risks relate to the environment. Thank you so much. Thank you so much. We appreciate you. So we have a couple of persons who have raised up their hands, and we'll be calling them one after the other. Please, let's make our questions very brief and concise, straight to the point, so we can manage time. So Mr. Nnamdi Ovis, please kindly unmute yourself and ask your question, please.
Yeah, good evening all. Thank you, Mr. Timothy, for this wonderful presentation. Please, I'd like you to throw more light on MOC, that is Management of Change. Thank you.
All right, so it is, thank you, Mr. Nnamdi. I was expecting that actually, because MOC is another big area that should be dealt with in the oil and gas industry. I said it's one of the 14 elements of the process safety management area as set by others. So what do we mean by MOC, management of change? Why do we want to change something? Because maybe okay, I think I forgot to speak about somewhere in your 8.1.3 to 8.1.5, which speaks about your externally outsourced, that's about your vendors and procurement. Yeah, I want to take that MOC from the procurement point of view now. Somewhere on this slide about 8.1.3 to 8.1.6 or 5 speaks about your vendors and procurement aspects. And that will now bring me to, where's the slide? What slide? What did I talk about? That will now bring me to extensive management of change. Now, let's assume that for there to be a change, for you to want to manage a change, that means is either the technology has changed, or the people have changed, or the environment is changing, or the procedure for work is changing, or there is a general regulatory change to what you intend to use against what you should use, or the materials that you want to use is not available, is now obsolete, you want to change for a better and a fit for purpose material. Now, there is a reason for a change, which I've explained, which I just mentioned. Now, how do you now implement that change such that it doesn't affect the integrity of your process or your products, which is either your petrol, your PMS, your DPK, your HEO, your butane, your whatever, depending on the industry you are. So how do you now, what is your procedure for management of change? It starts with, this is what we shall do. We have your change committee. Now, I want to take you a little bit into PMP, process management. Project management. Sorry, when you have too much things to say, you tend to, mix it up a little. Now, do you have a change control panel? Do you have, who is the business owner? Who is the process owner? Who is the product owner? Who are the panel that reviews all the change? How do you trigger a change? What are the level of analysis, risk assessment that you do to reassure you that this thing that is to be changed will not affect the integrity of your entire production plant, or the integrity of your entire process, or the integrity of your product? Have you put up that procedure to manage all those? Then what are the interventions? What are the regulations? What are the inspections? What are the observations you carry on during implementation of that change? Then at completion of the change, how do you now evaluate, how do you now examine it before you integrate the whole process back into your production process, or your extraction process, or your refining process? So management of change starts with, why do we want to change? Is it regulatory? Is it technological? Is it because we couldn't get the parts that we want to use? Is it because, you now begin to go into the technical details, technical specification of why this will suffice in the place of this? Now, if you've now been able to identify it, how do we now document the change? Do we have a change control panel that change request gets to, and they review it, and it's approved and recommended for implementation? Then how do we now, at that point when they are reviewing vis-a-vis the impact on the entire process, the entire product, entire people, entire environment? Okay, we wanted to use, let's say, because we said it is electromechanical, right? We wanted to use some level of, let's say, this 3mm cable for something. The specification is Nigerian cable. No, the specification is an imported cable. If you look at the equipment details, when you look at the spreadsheet of your process, you would have seen those specifications for each of the consumables. Because you can't get that, you now want to change it to something that is compatible and something that will give you the same end value. So you now begin to introduce it. At what level do we talk to people? At what level do we engage? At what level do we do our risk assessment? At what level do we implement it? What is the specialty that will do the commissioning of that change? No matter how small, a small valve like this can bring down a whole production plant. Then what are the different risk assessments and analysis that we do? And what are the things that we will now check before we now integrate that same? Because at some point we isolated it because we wanted to change something. Let's say we have 4 compressors. We isolated compressor 1 because we want to change something. Now, after changing that thing, because maybe it's bad or whatever, after changing it, or maybe we want to upgrade it, then how do we now integrate it back? So all those processes should be well looked at, should be well examined, should be well checked before it's implemented. So that's why I said it has to be very, very extensive. Do you understand me now?
Yes, I do. Thank you so much. I appreciate.
But we can still engage more further on, there are a lot of aspects on it which we can still discuss, but because of time, let's allow others to, I hope we've scratched it a little.
Yeah, yes, thank you very much, sir. I believe that if we should continue, you probably use all the time to
Exactly.
It's very wide. And even if you decide to use the route, is it the one that you showed, the expression that are called the what's it called, the Papa Alpha.
We can be there for 3 days.
Yeah, you can be there for talking about change management. So just let's go to the next question. So Mr. Jax Gibade, I think that's the next person. Mr. Jax Gibade, please let's make it brief. Please kindly unmute and ask your question.
Okay. Good evening, sir. I really appreciate the presentation made by Mr. Timothy. So actually, it's just my very first opportunity of having a training on this oil and gas management. So I just want to compliment he has really done a good. It's a pleasure to be on the platform. Thank you.
All right, thank you so very much, Mr. Jibade. Thank you.
Thanks so much for the feedback, Mr. Jibade. Please kindly mute now. So the next question, the next person we have Harima Issa Oyufo. Is that Nigerian? Please kindly unmute yourself and ask your question.
Who says I'm not a Nigerian? What's wrong? What's wrong with you, Wale? You don't know me. Huh? And you're a safety professional. How are you?
I'm very fine, sir.
Good. Now that you know I'm a Nigerian, sure I can speak, Abi.
You can speak, sir.
Okay, Timothy, thanks a lot for your presentation. I enjoyed it.
Thank you very much.
You certainly had a lot packaged in there. And like you said, you will need a lot of time, if not days, to go through every bit very well. But I think it's all captured. But I think I was a bit curious. When you listed the hazards, you put mechanical handling. There will be manual handling. You didn't. Maybe it escaped you, or you reserve it for next time. There was nothing about mechanical handling, and so I think people will want to know about that. And when you were discussing the just touch Piper Alpha, well, of course, we know the causes of Piper Alpha. There was transfer pump that was malfunctioning, that was removed, but nobody marked it as removed. And because I came to the North Sea shortly after Piper Alpha, so I'm quite aware of it. And the Mekondo one, I was involved as an investigator, so I'm actually an investigator and technical auditor. So
great to have you, sir.
I know about a bit about all this. But what I thought you would emphasize next time, whatever barriers you have, once you put a human being in front of a machine or a process, then you can rate yourself as 50% close to mistakes.
Yes.
Because unless a part fails, which is also a remote failure of a human being, the man who put it there, maybe substandard part or anything like that, you will find that whatever we do, when we say PP people, procedures, and
equipment.
Equipment. It's always the human being who is the problem. So, what, like you were talking about administrative controls, people rate it low normally of all the control levels, but you'll find is the key one, because if you have 10 minutes for your lunch break or for coffee break, then some clever manager like me comes along and say, no, we waste too much time on a coffee break. It will now be 8 minutes. That can tailgate to people's behavior. And some people will take their coffee to where they are working. And in an attempt to reach for coffee, they reach for something else. There will be a spill of coffee on their laps, and they will trigger something else. So it's us, human beings, who are the problem. Exactly. Even if we are automated, human beings still have to operate it. So I think when we were talking about training and competence, I was very interested, because that's where you need to capture people's attitudes. And it's the most difficult thing to do. So but on the whole, I think you did a good job. But when you do it next time, try and include many more salient points, like what I just said. And I noticed also you didn't consider, or you did, but you didn't say it, what happens before you get to work or coming to work, like transportation, commuting, helicopter crash, boat accident, those things. They kill more people than what happens on the drilling rig or something. So next time, let's have a bit more from you on that. Otherwise, I have no quarrel with what you did. It's very good. And I was going to miss this, but I just opened my eyes. I realized, oh shit, it's 5 o'clock already. So thanks anyway. And Wally, thank you, all of you. Thank you.
Thank you so very much. Those aspects you mentioned, they are very critical aspects, which, maybe because of time, maybe omission or whatever, but I agree completely with you that those are areas that should have, been, captured. But again, like I said, maybe there will be some additional, some extra classes where we would have an extent. And I'm happy to have very senior and experienced people on the call who can lend their voice to some areas where maybe we didn't scratch sufficiently. Thank you so very much.
No, Timothy, don't beat yourself up. It's continuous improvement.
Thank you very much.
It's continuous improvement. Next time you will remember something you forgot this time. That's how it goes. So,
thank you very much. Thank you.
Thanks a lot. Yeah, God bless. All of you, good night. Oh, I will go find whatever I will drink.
Thank you very much.
All right.
Yeah, cheers.
Yeah. Thank you so much, Chad. Thank you so much, Chad. Like we said, you always look up to having professors, experts like you to also join us on this section. I also take responsibility because I actually told Mr. Timothy Aluko to make it as concise as possible. So he's willing to touch every aspect. But I said, the only time we have is 2 hours. And even apart from that 2 hours, we have question and answer section. So I actually told him to limit the scope of discussion. So maybe next time I would give space for kind of discussions like this so that the facilitator will be able to go to other areas. We apologize. Thanks for your feedback.
Excellent. I think what might even help, you know all those blocks in the process that you drew out from number 1 to 10 or whatever. Next time, take out a block, maybe the first one.
Exactly.
Let's deal with it in detail. Let people understand what it means.
Exactly.
Like when you, like the period, like the one of leadership, I think it was item 7 or whatever it was.
5.
You really need where you deal with policies and procedures and planning and before you get on to management intervention, like if you take out the blocks bit by bit, if you have the time, today we discuss this block. So newer people or younger people will begin to make note, expecting more next time on the next leg. So well done. But
thank you very much.
As I said, excellent. Well done. Cheers.
Thank you very much.
God bless. Cheers.
Thanks so much, sir. Thank you so much, sir. We really appreciate that. I've tried to connect on you on LinkedIn. I think is it Mr. Victor Kazim Isa Oyofo? Am I correct, sir?
No, I'm Harriman Oyofo. Harriman Isa Oyofo. I'm Kasim's younger brother. Okay. He is a geologist. He's not.
Yeah, I tried to you on LinkedIn now. So that's
yeah, I put out a lot of publications on LinkedIn, and there was one that was so widely received last week. Incidentally, it was about emergency response.
Okay, so, that is okay. H Isa Oyufo. Okay.
Yes, that's
yes.
me. Okay.
Well good, sir.
Yeah. Okay, guys. Thanks, huh? All right. Okay. Well done.
Thank you, sir. So we have the last person, Injita Botan. I don't want to support myself this time around. So go and guess again. So Injita, Mr. Injita, kindly unmute and ask your question, please.
Good evening, sir.
Yeah, good evening.
I'm very grateful to have been part of this international session. I'm Martin. I'm from Cameroon, and so from Hoya. I'm a safety practitioner too. I really appreciate the content of the exposition that was just made. It's very rich. I've learned much, especially with in the oil and gas industry with regards to safety. I would have loved that the session to continue and go on and on and on. Like the previous person just said, he could take every slide and discuss in detail. So quickly, I just wanted you to throw some light on the standard operating procedures. I don't know who has to write the standard operating procedures. Is it the technician or the safety person? And how can we monitor and ensure that that is followed and implemented? Is it recommended? What can be your recommendation? Thank you.
All right. All right. Thank you so very much, Mr. Njita. Just like a risk assessment and a job safety analysis, you know, there must be a procedure for managing risk, for managing exposures on the job, which most time it is done by the team to do the work. You know, like let's say they want to do a valve replacement or a gauge replacement or whatever. The risk assessment for that task, I'm going back to your question. I just want to come from this angle. The risk assessment for that task is done by the mechanical guys, the fitters or what have you, that will do the job in conjunction with the safety people. What the safety person is just doing for them is they will give you the guys to do the job. They know the process more than you. They will give you their method statement. Oh, the step-by-step, you know, risk assessment and job safety analysis deals with the step-by-step of the task. They'll give you, okay, from this activity, we'll go to this activity, we'll go to that activity, so they will now tell you what are the exposures on each activities. So for the risk assessment for the job is done by the team, not by the safety people. The safety person will be there to now guide them on, okay, let's take it from the hierarchy of controls. What are the, existing, what are the additional things? Then what are the residual or inherent or whatever still remains? I haven't explored all those things. That's the same as your standard operating procedure. Your standard operating procedure for each process, you would have first set your procedure for setting your standard operating procedure for all those processes. That's your 8.1 under your operational planning and control. Now, your standard operating procedure for each process is done by the process owners, process leads. Well, that depends. I don't know what you have on your control of your document control procedure or your control of documented evidence procedure. Who approves what? Who sets what? You see, all these documents, all the procedures are interrelated, are interlinked. It depends on what you have on your procedure for control of documented information or your procedure for your document control procedure, or whatever you call it in your organization. Who approves what? Who documents what? Who establishes what? Who prepares what? Who reviews what? So again, but in the ideal process, going to your control of documented procedure, your standard operating procedure for each process is done by the process owners, the team. because they know the process more than you. You can also, the safety person can just be part of the reviewers, such that you can now lend your hierarchy of control expertise, your risk management expertise to whatever they are doing. But primarily it is prepared by the process owners. But you can now lend your expertise, then it is prepared by them, maybe jointly reviewed by them and the safety persons who maybe have some mechanical, some electrical exposure, some competence around that. Then it now goes to a super management who adopts and approves the process. In some organizations, you have some audit and compliance. In some organizations, you have document controllers who reviews in conjunction with other subject matter expertise, then now appends or sends to the top management for approval. And that same level goes through whenever you want to review. It depends on what you have as your review syndrome on your control of documented evidence procedure or your document control procedure, where, okay, maybe we review every 2 years, or if there's technology change, we review, or if there's management change, we review, or if there is a political change, we review, depending on the aspect of, aspect of the job or aspect of the process we are trying to create an SOP for. So you see, there is something very dynamic, something a bit complicated, a bit technical, but again, primarily, what do you have on your procedure for control of documented information, your procedure for all those things? Who establishes what? But the best practice is that the process owner establishes it level by level. Then you might, as the safety person, you might be part of the reviewer. In some places, you have your document controller who does some level of review, then throws to top management for adoption and approval before it now becomes a document that guides the operation. Do you understand me?
Yes, thank you very much, sir. Very clear and on point. I'm grateful. Thank you.
All right, thank you so very much.
All right, thank you, sir. I think the next question we have is on the chat platform by Oluwa. What are the clause overview for 1 and 3, and are they called non-auditor? That is the first 3 clauses that addresses the beginning of your ISO.
Okay, so for clause 1, I think clause 1 is around scope of the management system, which is, the normal same story like your. How many of you read the manual of your phone before you start using it? So it's like your manual.
Yeah.
And I think clause 2.0 is about your normative references.
Yes.
References. Then your 3.0 is about your terms and definition. This is hazard, this is risks, this is interested party, this is contest, this is documented information. It's all about all those. You are not audited with all those things. Your high level structure is, which they call HLS, is from 4 to 10. And that is where you are audited. That's what you are audited with, or in line with, or whatever. So your 1.3 is just like 1 to 3 is like your normal stories, but you are not audited with all those. Your high level structure is from 4 to 10, and that's what you are audited with. Thank you.
This will be the last question. Please let us make it brief. We need to end the session now. I think we have Mr. Sunday Odibo. Please, this is the last question. After this, we will not ask any other question again. So, Mr. Sunday Odibo, please kindly unmute yourself, sir.
Okay, thank you. Good evening, everyone. And thank you, Mr. Aluko, for this presentation. Mr. Wale, the moderator. My quick take is on the hierarchy of control. In the hierarchy of control, you said in the elimination, substitution, it's not possible to operate in the hierarchy of control in some instances you gave.
Based on those instances.
Yeah, so I want to, okay, some instances. I want to say, is it that it's not effective or is not in use in the oil and gas, or is it?
No. I gave some case studies. I'm trying to display what we said again. I gave some case studies. Based on that case study,
okay.
Let me try and display it. Just hold on. I gave this study that, okay, high pressure oil gas from the reservoir, it is expected to come at high pressure because the more the pressure, the more the pump out you get. So based on this case study, I said elimination is not possible for this example. Not that it is not effective. Of course, you know, by your hierarchy of control, you know that the most effective is elimination, then engineering or whatever. I just tried to change this kind of substitution, the engineering, the one in the administrative and the rest of them. So based on this example, based on the case study here, you know, you apply hierarchy of control to all problems.
Yeah.
Now, based on this problem, it is not possible to eliminate pressure because you need it to get this, what you want to get. If you eliminate it, that means you won't extract more from the reservoir. Now, how do you substitute it? You can't substitute. You know, it is based on this example, not that this is not practicable. Of course, a lot of processes, you use elimination, you just eliminate it, you substitute with whatever, you will use some level of engineering. But based on this case study that I gave is what maybe I should have removed something on this heading so that it is well understood. I hope you understand what I'm trying to say.
Yeah, I'm with you.
It is 100% effective. It is 100% applicable. But based on this case study, you need that pressure for the work you want to do. Because the more the pressure, the more the pump. In fact, you still introduce pressure at some point. That when I talked about fracking, remember I talked about fracking.
Yes.
So you need the pressure, you know, that's you inject liquid at high pressure into the rocks and balls or whatever, so as to force open the existing fissure and extract oil and gas. So you need it. So you can't eliminate it from this process, this example that I gave.
Okay.
But it remains very effective.
Okay.
Other problems, yes.
But okay, I get you now. Thank you. I get it.
All right.
Thank you very much.
Thank you.
On
this note, my dinner is getting cold.
Okay, we are rounding up now. We're rounding up now. So thank you, everyone. We appreciate your presence. Like we said, to have a review for those who missed one or two parts of the section, we have it live on YouTube. So after this section, it is already live on YouTube. So also the material, I got communicated to be available for us to share around for us to learn from. And if you know that this is a property of Mr. Timothy Aluko, so we should know how to use it and where to use them. Thank you all for coming. Thank you all for your presence. We have so many professors here. We have so many experts here. Thank you all for making it up to us, for joining from the beginning till the end. We appreciate your presence. Next week, we'll be having another section, and with that will be handled by me, because we are going to talk about our 3-day technical safety training courses that we've been delivering. If you are working in an organization and you need us, and you need your colleagues, your workers, your junior colleagues, your senior colleagues to join in the training section for the 3-day technical safety training course. That is not free anyway, but the overview for next Sunday is free. We'll be touching on some salient points. We'll be talking about accident investigation techniques. We'll be talking about safety dashboard, HSE dashboard. We're talking about those things you've not heard before concerning detailed job asset analysis. And those are the basic content of the 3-day training course. So if you are interested in the training course, you can send me a message. It costs for physical section costs only 20,000 naira. For the virtual section costs 50,000. Sorry, for the virtual cost 20,000. For the physical cost 50,000 naira only per person. But we are coming as a group with pre-organization. We have discounts for you. We promise here. We have our first batch last month, and the feedback was really massive. And it's a training for everyone to join. But this coming Sunday, we'll be having an overview. Just an overview of the old course, so that you know why you need to attend this training. We all have, some of us have my WhatsApp number, 08028657826, 08028657826. Contact me for further information concerning these 3 days technical training courses. Really appreciate. I can see Mrs. Teresa Alayenka. She was also present in the 3-day technical safety training course. I really appreciate you, man. Mr. Sunday too was also present in our first batch for the 3-day technical safety training course, and a couple of people who are here too. So thank you all for coming. Thanks for your presence. Thanks for seeing value in what we do and for joining us always. We appreciate you, Mrs. Timothy, Mrs. Teresa, Mr. Aziz, Mr. Sunday, Mr. Tunji, Mr. Victor, Mr. Adam, Mr. Festus, Akim Mukhtar, my good friend, Mr. Jax, and every other person from every part of the world. Thank you all for coming, and we wish you a good week ahead. Thank you, and God bless you. Bye-bye.
Thank you, sir. Happy weekend. God bless you all, too.
Thank you. Thank you.
Yeah,